Hi guys, and welcome to yet another Genome2D Devcast. Today I'm going to talk about the new Unity context for Genome2D. I've posted on Twitter like a week ago that I'm working on it and it's in alpha stage and you can test it, and some of you wrote to me back that it's not running, there are some problems you've encountered. So I decided to do this devcast to like focus on this, how to actually run it and how it works. And I'm going to talk about the idea behind the Unity context, why I decided to do this and what it actually is. So some of you may even remember my post like 2 years or 3 years ago when I tried to do the Unity context for Genome2D. It was basically drawing some sprites. It was the basic example of drawing sprites through Unity, and it generated a lot of game objects and stuff like that. So back then, Unity wasn't even ready to be able to handle something like that. So I've postponed it. I focused on the C++ target, but now I am back to Unity. Why? Because Adobe Air is not getting as much love as it used to or as it should. So there are some questions around it, and we are exploring another options. If this platform or if this target is not no longer viable to run our mobile games, we need to be ready to switch to something else. And what something else can be? Something else can be either like some native stuff like C++, which is doable, and the C++ context is actually in alpha as well. It's a private repo using Lime. And another way to do it is Genome2D WebGL target using some kind of wrapper over it. So you would have a native app over WebGL, and then the final one is using a third-party engine to run it. So I chose to do it this way, to use Unity. Why? Because it's actually quite easy to do from all the R&D I did. But the major reason for me or for us as a Pixel Federation was that we are using Unity for our new projects. So we will bring the whole pipeline together. So if we are doing some shared libraries or using a third-party stuff for the ad networks and in-app purchases and stuff like that, we can reuse it through our whole company, even for the Hexi projects once they are running in Unity. So why we are not refactoring all our legacy projects to Unity? The answer is actually pretty easy. The problem is that we are doing like weekly or bi-weekly updates for all our projects, and it's not feasible for our guys to like switch to another language and do all this refactoring, and some of them may even struggle with C# in some places, and it would not be feasible to stop the whole work, stop the feature set of the games just to switch to another engine. So I decided to write this Genome2D context so we can port all our existing projects to Unity without changing any of the code base inside our projects. There will be some changes, like the stuff that's not bind to Genome2D abstraction, or there is no Genome2D abstraction yet for it, will need to be done, but all the stuff that's already bound to Genome2D abstractions will just run in Unity without any changes. There are some stuff that needs to be done. For example, there is no sound inside Genome2D. There is some stuff with touches and stuff like that that will need to have Genome2D abstraction before anyone can bind it. Or if we don't do any Genome2D abstraction, we will need to implement the Unity version for it for all our projects. So that's why I'm doing it, and it's actually going rather well. So let me show you how it actually works and what it is. So it's a new context inside the Genome2D repository, and it's called obviously a context unity. It's another submodule. I've just updated it like an hour ago, and you can access it as any other context in Genome2D. It implements the EG context interface, but it will not compile a binary for you. It will basically just transpile stuff. I even created the workspace for Visual Studio Code because I'm using that to edit the hexi sources. So what do you see here? There is this testbed application. I will get to that. It's basically a Unity project that will be used to run the Genome2D project, because once again we are not creating a Unity binary here. We are just transpiling all the Genome2D stuff to C# that will then be run inside Unity. That's what's the major change between these and the other contexts. Then there is this plugin. It's basically part of the source code inside Genome2D Unity context that's written in using C#, not hexi. And why I'm doing it? It's rather easy explanation. There is some stuff inside Unity, or basically inside C# that's using C# functionality that's not part of the hexi. For example, if we are loading something, let's just switch to the Unity asset. If we are loading something inside Unity, we are using this web request and getting and stuff like that. But as you can see, there is no event model around this. What it does is using the yield, so it basically waits for the return from this function. Is an asynchronity inside the language syntax, which is not part of hexi. It can be done. I've seen macros to do it, but it felt for me as a hack, so I decided to do it the other way instead of using the custom third-party macros inside the Genome2D. So what it does, it waits for the request to be processed, and once it returns something, it will process it. So I did this whole wrapper around it to just do the event uh, model basically around it. So you just send this function, this callback reference, and what it does, it calls the callback. So we switched from the yield to just the callback model. So the hexi version of the Unity asset basically creates this, and it assigns the reference and it gets the callback. There is no yield inside hexi. There is some stuff missing, as you can see, like the error is not returning any callback or calling any callback. It's just using the debug log of Unity to just shows us to show the error. I've left this for later because this is just another, like, I know how to do it basically. So I'm now focusing on stuff that it's still not as predictable as this. I mean, this will work. If I add these five and other actions there, they will work. So I'm now focusing on all the stuff inside Genome2D that's not as clear if it's going to work, how it's going to work, and stuff like that. So this will come, but it will come later when all the other stuff is done. Uh, Another reason I'm using C# for some of the low level stuff, like you can see the G native Unity context, because in hexi you will see this G Unity context. And as you can see, if I open the G Unity context, and if you see like draw, which is the implementation of the EG context interface, you can see it's doing pretty much nothing. It's using G native context draw. It just sends it to another function, another instance. And this is the instance of the native context, which is created using C#. Why I'm doing this? I want to avoid any type of overhead that the hex transpiler creates over it. So this is just pure C#. We are working on arrays. We are binding to the shader. We are deciding what's going to be batched together and stuff like that. So all this is using pure C#. just to avoid any overhead that can be inside the hex code. Why I did this actually because first I decided to even implement the native stuff, because in Unity you can implement managed plugins and unmanaged plugin. Managed plugins are using .NET, it's the C# stuff. This is a managed plugin. You can even create unmanaged plugins like using the C++ stuff, but then you will need to do all your allocations basically, and what you will need to do as well is like you will need to implement it for all the platforms where the plugins need to run. So I did this first. I actually had two versions at the same time, but once I knew that this is fast enough, I've decided to go this managed way. If there is some problem with performance later, I can still go the unmanaged way. I can create a G native Unity context for Android, for iOS and stuff like that, and using just the pure low-level APIs. This works. It creates all the Unity structures and renders the stuff. This is the only way how to render anything from Genome at the moment. Uh, in this single class. There is no other stuff in Unity or in Genome that's rendering inside Unity. This is the bind point basically. Talking about bind points, if you know how Unity works, there is no main stuff. There is no you always need to have something in the scene to run it. Basically, there are hacks around it, but just to be clear, there needs to be at least one game object and one component on it. So I needed to find this bind point for Genome2D, because in WebGL, in Flash targets, in C++ targets, Genome2D runs as a main, or your project runs as a main, and it binds and creates the context. It runs its own update method and stuff like that. For Unity, this was not so clear, and what I had to do, I created. Unfortunately, I decided to create it for use the G project for it, which is in Genome2D core, which should be abstract. It's the high level part of Genome2D. So seeing stuff like this, like if C sharp or if not C sharp and stuff like that, inside the high level core is not as clean as I would like to, but for the moment it works. Maybe I will change it. The obvious change is to move G project to context common, or for and then implement it for all the contexts as so fit. I mean, there should be only one inside the context common and then an override inside the Unity context, because all the other contexts have the same G project. But I decided to use the G project which will extend the mono behavior. So your project will extend the G project, and then you will just add this mono behavior. Since it's a mono behavior, you can add it to the game object inside Unity. You will add this to the game object, and the single game object, the single component, the mono behavior will handle everything for you. There is nothing else you need to do inside Unity. Uh, Basically, everything will be decoupled from Unity. Your project, everything will be processed inside Genome2D, inside your project code base and stuff like that. There is no coupling anywhere else. There is some runtime coupling, like for example, Genome2D will create a Unity camera for you, but then there is nothing else. So it will be decoupled, and once I decided once I decide to port this to, for example, Unreal 4, it's very easy. I will just change. All I actually need to change is this plugin. I can create a C++ plugin for Unreal, and I can run Genome2D inside Unreal, because I can transpile obviously using Hexy to C++ stuff. So that's the bind point. So as you can see, for example, there is inside examples there is this Unity test project example that extends the G project, so you can add it to a game object, and it will run this example. One more info. All the examples for the Unity context are inside the Unity context submodule, inside the example stuff. So far, I'm not using these Genome2D examples submodule, which is used for all the other contexts. because it's still in an alpha version. I am testing stuff, and there is something different between an approach to examples inside the Unity context versus the versus all the other contexts. I will work on it to just merge it together, but that's not main focus for me. For example, there is this native gen macro and stuff like that that you will need to use for it to work. As you can see, I'm using a Unity engine directly inside the example. This is not no longer needed eventually because I've I've put the mono behavior inside G project and stuff like that. But since I'm working on it, still working on it, I didn't want to like have an overhead to make the examples work from the global repository. I've created these custom examples just for the Unity context, and then I will move them to the global repository. So let's look at the build file. It's basic XML. It's inside the repo itself. What it does is includes the context common, obviously because we are implementing the same common using the high level context core, using the Genome2D spine because there are spine examples, then they use the spine libraries, and then we are using these source files for the Genome2D context, the Unity context. Then I'm including the examples I've just mentioned. Then I'm including the dynamic library for the which is written inside in a C sharp. It's part of the repository. It's open source, as I've mentioned, so you can even change that if you want something more low level. You can work with that and stuff like that. Then I'm using the Unity engine for library, basically just to bind to Unity engine, obviously, and then I'm using the extension UI. This is used so far only for the stats because I'm creating the frame rate counter and stuff like that using Unity UI. It's not using the custom render method I just mentioned because this is similar, for example, to the WebGL stats, which just create a div element and stuff like that. So stats are not really rendered using Genome2D. They're just rendered after Genome2D rendering anyway, so they don't even add a draw call and stuff like that. So they're using always the part of UI, native UI for the platform it targets. There is just some Sorry, my mic just got turned off. These HyperX headphones are cool, but if I'm not listening to anything, and I'm not, I'm just talking, they think that I'm not using the headphones and then they just turn off. That's what happened just now. Anyway, let's move. I'm using Hash script because now I'm working on implementing the runtime Hex script, and I'm using Box2D library. One of you guys actually mentioned that Box2D doesn't work and it breaks down the compilation. Yes, it does, because Box2D is not part of Genome2D. It's a Hexlib library, so it needs to be installed using Hexlib, Box2D, but I'm using it for the physics example. Unfortunately, inside Box2D, they don't abstract over Sprite. They are using Sprite, which is part of the Flash package, and Flash package is native for Flash platform, so it will not work for a C# platform. That's why I changed their source code. But obviously, if you download the Box2D, you will need to change it as well. What I did is actually I've changed all the sprite references to dynamic references because the sprite is used just for debugging inside Box2D. I don't really want to debug, so I just used dynamic, so the compilation doesn't break. It would break in runtime because dynamic is nothing basically, but for my purposes it work. If you don't want to modify the Box2D, you will need to just mark the Box2D and then remove the physics example which uses Box2D. Box2D or the physics example is actually implemented for the NAPE, which is another physics library using Hex, but NAPE uses kind of strange preprocessor, and it uses custom getters and setters. And since I didn't mention it yet, since I'm using hex 4.0 release candidate 2 for all this transpilation and this Unity context stuff, Hexi 4.0 doesn't support custom names for getters and setters anymore. So nape is out. You cannot compile nape unless you change their source, basically, because they are using custom names for getters and setters. I've just let it. It will work for all the other platforms if you are not using Hex 4.0. So that's let's return to the build file. Okay, what I'm using .NET version for 0, no root. There is some other stuff. For example, if you don't want to hex to generate all the line informations, you will use what I'm talking about. Let me show you a little bit. This is, for example, one of the Genome2D classes, transpile to C#. This is what will be generated using Genome2D if you run the file. As you can see, there is all these defines there here. And what it does is, if you have a problem in your project inside the hex and you run into a error or during runtime, it will tell you where in the hex code it actually crashed. So all this information is there. So if it crashes here, it will tell you that it crashed inside the G static manager on line 16 instead of crashing inside G static manager C# line 39 or something. So it's very clean and you can read where the problem is inside your hexicode, because you don't really want to edit this transpile stuff. This transpile stuff will be overwritten each time you run the build file. This is to erase generics, and Hexi will create like static stuff for you. This is to remove inline stuff. I had some problem with inlining once I started doing this Unity context. That's why I have it here. Uh, if you run into some problems, there may be some problems in using inlining when you transpile to other stuff. But so far, at the moment, it works, and I will try to keep it that way. We are not doing any compilation. We are just doing transpilation. This is where the transpiled code would be saved. What we actually can do, and I've tried and it works, instead of using transpiled code, so instead of creating this C# for you, Hexi can create a dynamic library. So all this will be inside the huge, not huge, it's not really that big, the dynamic library inside the dynamic library, so you'll not have access to the C# files, and you can just communicate it with it as any other library there is. So your whole project can be basically a DLL inside the Unity project if you want. And obviously we need a macro to include all the classes. So let's look at the project. If you open the test bed I've mentioned, there is this test bed inside the Unity context. It's a simple Unity project. I've just updated it to Unity 2019. If you open it, I've actually deleted the game object was there. There is this single scene. It's called testbed, and it has this single object. Let me delete it once again, so I'll show you how it works. What we have here is this is the code where all the transpiled code is generated. You don't really want to touch this. I'm touching it sometimes when I want to like fix it, or if I want to see what's the problem inside the transpiled code, because there were a lot of problems. Let's mention some if you are going to work with it, or if you are thinking about transpiling your stuff into C# using Hexi. For example, there was a huge problem with default parameters for static target like C# using Hexi, because in Flash or in WebGL I'm using a lot of reflection, because all the prototypes and stuff like that works with reflection, where I need to call a constructor using reflection. At the moment when I'm calling this reflection, I don't really know what type of parameters nor how many parameters are inside this constructor. So I'm using default parameters. But this doesn't work in C#. You need to specify what parameters are there and how many are there. So you cannot, your default parameters in hexi will not work inside C# when using reflection. So this is actually two problems at once. First, I need to get rid of the default parameters. That's what I did, and if you check the code base for all the other contexts, I called it breaking change, but it's not a breaking change. It's more of a now you need to put the parameters there yourself instead of just letting Genome2D put it there. So if you run your all Genome2D projects using the new Genome2D, using any of the contexts, you will need, for example, specify all the parameters for all the draw calls and stuff like that. Anyway, and the other problem is that I had to know what parameters are there when I created constructors for all the prototypes, all the stuff that is prototypable. So I created a new, basically I can show you, I created a new helper function or a helper, oh it's inside the helper class. This is it, prototype constructor lookups. And basically it just needs a name of the prototype. These are all the stuff that is prototypable inside Genome2D. And this is array of the default parameters it uses to create an instance of it. And this is what the prototype factory inside Genome2D uses to create all this stuff. The problem is that if you create your own prototypable stuff, if you used it in your projects and you implemented e.g. prototypable, you will need to add your class or your prototype here with all the parameters. Or you can have it with an empty constructor. If you have a e.g. prototypable implemented, but your constructor doesn't have any parameters, you are safe. You don't really need to do anything. That's what most people do anyway. But if you have parameters, you will need to add it here. I will try to do this or create this class at runtime or at compile time using macro. For example, if you know there is this like helper class. This is a huge class actually, but it's generated during runtime using the macro, during compile time using the macro. So I will try to generate this class as well, some type of macro enumeration on the constructor parameters. It shouldn't be that problematic, but I'm just avoiding that at the moment because it's not necessary, and I want to, as I said, I want to focus on stuff that's a must-have for the Genome2D to work inside Unity. So that's a problem with C# in Unity if you run into it. Another problem, for example, was that if you are using some abstraction, it's I mean there is some stuff inside Hexi as you know that where you can like type to the abstract stuff and stuff like that, but you can run into some really weird stuff like an instance of a class where this is a null basically. So we will run into stuff like that. Or for example, if you are talking about the default parameters, if you are using default parameters inside C# using Hexi, you can run Hexi tries to, for example, you have, let's say I have a constructor with parameter which is a float, and its default value is 0. If you check the transpiled code inside the C#, it will actually be, I mean, float inside C# is single. That's not a problem. If you want double, or a float inside C# is double. If you want a single, which is a real float inside C#, you would need to use a single. Anyway, it will not be double. It will be null double. It will be generic over double, which is it will be a null safety wrapper around it, which is a problem. I mean, it's cool that Hexi does this, but it's a problem because if you then call, for example, this constructor over it and send a 0 to it, like because 0.0 is a cool float double value. It's valid value. It will tell you that it's not valid value for null float. because it's not, but but because this hexe generated this null safety wrapper around it for no obvious reason, as I can see. But this is the stuff that you will need to work with when you are using C Sharp. So let's back to Unity. So let's create the empty object. It's an empty game object. Let's just reset it. So, and now you create a Unity test project. This is the G project, which is a mono behavior, so we can add it to the game object. This is all you need. This is where the genome binds to Unity. If I run it, it just runs the Genome2D inside it, and everything else is handled inside. We have these stats. There are 3 draw calls. The frame rate drop is due to the recording, obviously. As you can see, it created a camera for you. It had to create a camera. I tried to do it without it, but you cannot render anything inside Unity if you don't create at least a single camera. As you can see, it's a perspective camera and stuff like that. Don't really read into it. This is not true because I am overriding everything at the low level. Obviously, I'm using orthogonal projection. I'm using my own custom projection matrices and stuff like. So I can actually show you, because if I can disable this and I can use camera example, which is another example using Genome2D. And as you can see, we have this single camera here, and I'm actually, there are these stats, which as I said, they are using UI, but it's a single Unity camera, and you can see inside Genome2D there are actually 4 cameras. So I'm creating custom projection matrices for all these 4 cameras, and I'm not generating, which was I was thinking I will need to do, but uh, luckily there is a low level access to it. So I'm creating 4 Genome2D cameras and rendering them inside one render loop inside the camera of Unity. So there is nothing else bind to Genome2D. It's completely decoupled from it. So I can show you a few any other examples if they will work, because for example particle, let's show you. I think I used some kind of particle example for my last post. What we have here, let's say, let's try physics. I'm not sure it will run. I didn't try. Oh, it runs, obviously. I'm changing the gravity. So let's look at it. Let's look at the example. So the physics example is using the box2D. Uh, it's using the actually it's extends the abstract example. Abstract example is the G project. That's why it's a mono behavior, can be bind to game object. So physics example. Let's say I want to create, let's say, okay, 100 cubes. It's okay. Let's change the gravity in a different way. Or let's don't do. Okay, let's don't do the grid distribution. Now we will create the boxes. I will write too many arguments at 90. Okay. Okay. I'm not reading after me. Ah, 9, too many arguments. Where are too many arguments? It's random. Oh, I need to do it like this. There is, I always because I'm using all these languages. Sometimes I forget how the math functions work inside different languages. So hex uses the normalized random from 0 to 1. So now there is just this error inside spine. It's basically a code base of the spine guys for the hexe. I've tried to change it. I actually optimized it a lot because they are using string for everything. A string is, as many of you know, it's a pain for garbage collection. So I changed it to enums and stuff like that. But then I stopped myself because if you want to update the spine library, you are basically out of luck. All my optimizations will go out of the window. So I did it for myself. But if you are working with the spine stuff from the spine guys, you you will encounter this anyway. So now let's wait for Unity. It just compiles the stuff. Now it's compiled. You will see some warnings like callback stuff. It's not hiding. I will try to look into this, but it's not really relevant to fix anyway at the moment. Let's just run the physics example. Okay, now you can see the physics is actually working using box2D. This is box2D from the hex. It's not because Unity has box2D inside itself, but this is the hex version of the box2D. So if you have any other stuff, let's say, okay, what we have here, UI example, a simple example for the title. This is actually using the prototypes to create this simple UI. It's rather too simple. Mouse example. Okay, you can see that mouse works. We have these info logs, and you can see that once again it shows you where is the stuff inside the hex file instead of the C# transpiled code, so you can debug it. All this mouse handling and stuff like that is done purely on the Genome2D site. This is not Unity UI. Uh, it's just low level. So if I once again, if I decide to move it to Unreal, I can move it to Unreal in later. Or if anyone is interested, I can look into that. Do we have anything else? Just try simple particles. Okay, one more. For example, spine example. Oh, I put a lot of instances there. If you, as you can see, let me just show you. This is the spine example. This is count is a public variable inside the hexi. It's an int using some default value. If you compile this, and you need to use a native gen, obviously. If you transpile it to C#, it will work as any public property of and have phones turned off. Anyway, it will work as any public property of the C# class, so it will be visible on the mono behavior. So now we need 500 examples, and this is 500 instances of dig using a single draw call inside the Genome2D. If you look at the scene, there is nothing, obviously. I'm just working with the game window. Okay, let's wrap up. I don't know if there is anything I should mention. I should mention maybe what's here as well, because I've stopped at this code. This is the code that's transpiled. This plugins directory, this is just my JetBrain stuff. Here is the plugin, the Genome2D native plugin DLL. So if you compile it, if you modified it anyway, you need to like copy it here. I will move it into the plugins folder later. This is the testbed scene, obviously, and there is this resource folder. I'm using a single shader I wrote for Genome2D purposes, because this is what Genome2D actually just need. It needs an unlit shader. We need to be able to change the blend mode. We need to we don't really need to Z write and stuff like that. I'm using color inside the vertex buffer to use the colorization and alpha stuff on sprites. and stuff like that. It's very simple shader. I will probably create another shaders for the 3D stuff, but this is so far the only shader that's needed for all the Genome2D stuff. And then here are the assets. These are all the assets that you need for the examples, basically. So as you know, this will be compiled into the APK or IPA file if you compile to mobiles. So I handled loading of them inside the asset manager inside Genome2D. So if you just tell the Genome2D, for example, let's look at the physics example, or okay, let's look at the abstract example. If you tell it that you want to load something from the asset folder, it will know that it's not an URL. So it will try to look inside the resource folder of Unity. So this will know that you are probably looking for something that's inside the resource folder inside Unity and load from there. Okay guys, I think that's pretty much it. I will update it a lot in the next couple of weeks, months. So if there is something you need uh, or anything that I missed, just drop me a line. What I will focus next on is basically I want to have the Hexi scripts running at runtime. Next, I want to start working on render texture because that's what I need to pack atlases and stuff like that. But I've already checked it out and it's pretty easy to do. And finally, I will work on disposing stuff because at the moment I didn't really work on any dispose. Textures are not getting disposed because the examples don't really care if there are too many textures and stuff like that. So for a huge project, obviously the dispose stuff needs to work. So that's next on my to-do list. Once I'm done with that, I will move to another stuff, but that will handle most of the stuff that's probably there. And as I said, I will also focus on stuff like sound and things that need to be abstracted for our projects to work inside Unity. Okay, that's all folks, and thanks for stopping by.